continuing the discussion from the man machine relationship, given the kind of issues it would raise, it would be a good idea to take a look at how this relationship can be made smooth, how it can be made functional, and how the interactory concerns which have been highlighted as we went along can be handled best at a design level or at a production level itself. The man machine component selection or the human machine interaction component selection begins at a design stage, and design can simplify their search for appropriate switch or HMI components by carefully analyzing their application requirements and then determining the following. If you determine the application requirements, then it becomes a technical issue, and the technical issue can be handled in the following manner. It can be handled through proper electrical ratings, it can be handled through actuation preferences, momentary, maintained, rotary, and physical configurations and mounting needs. Special requirements such as illumination markings and environmental sealing would help. Brings us back to one of the key propositions of this analysis, namely, a lot of engineering problems are sorted out through managerial tools, and a lot of managerial tools may be easier to apply if the engineering underpinning to it is consistent, and engineering underpinning to it is amenable to easy manipulation. Just as there are HMI component selections, so there is the issue of the color scheme, which is central to understanding the man machine interaction. The key to effective use of color is simplicity, like everywhere else. The purpose is to avoid too many colors or flashing alarms. Stick with the traffic light model for the key action. If you stick to the traffic light model for key action, what is it that you get? You get red for the stop or the failure, you get yellow for the warning, and you get green for OK start, that is go and pass. In other words, it is always possible to have a situation where the color scheme to which a user is conditioned is put in place for the kind of messages which you want to give at an operational level to the gadget user or to the machinery user. From the color scheme, we move on to the information presentation, and I would like to go through these three suggestions. Here again you notice that the emphasis is on simplicity, not crowding the screen, avoiding clutter. Therefore, the operator does not have to go in for the required information in a painful manner with possibilities of errors. This helps smoothen the man machine relationship. Then there is always scope for the user feedback. If the feedback is critical to the ergonomic industrial design, then there is a case for revision. Make sure the results of pressing a control button or toggling a switch or entering a command are absolutely clear. Determine if operator feedback is visual, auditory, tactile, or a combination of multiple techniques. Now, one does not have to get into too many of these details, but the proposition is a simple one, and later on I will be giving you some suggestions on how to handle it. As of now, all that you have to do is recognize that, like in many other areas, engineering and management have to move hand in hand to make sure the operational aspect is handled effectively, so that the machine works at an optimal level and the individual operating is not put through a painful process. Let me illustrate what I am saying with examples of the usability problems. Please go through this listing. Now, here are 4 examples which would touch everyday life, which would touch most people who can afford, say, a TV or a car or a software, and indeed even those who can't afford these gadgets will have to deal with, say, travel issues, and therefore would need to get onto a train. In each case, you can't expect the user to understand the technology, to understand the changing commands as the product evolves from one design to another. So, engineering can be used to keep it simple, so that the interface from engineering to user is made as simple as possible and therefore, as effective as possible. It seems to me that it is important to recognize that, be it a TV, be it a car, be it a software, or be it even the train system, engineering cannot be used as merely a framework of reference for handling an effectiveness issue, effectiveness for engineering results. Effectiveness here has to do with components of user comfort. I will give to you further examples where user comfort will have to be factored in to get into man machine relationship. For example, moving away from lay user systems to technical situations which may be industry based or which may require a subject expertise, one has to recognize that one has to design the control room of a big factory, as is stated here, plant, so that the operator can overview all the processes and also get detailed information about a particular process. So, the control room has to have an integrated view, and also have a limited perspective on a particular process. So, it is both atomized and integrated. How to design a medical apparatus so that the doctor does not harm the patient by accidentally pushing a wrong button. A very operational perspective, but a very relevant perspective when it comes to man machine. How to design an apparatus so that people with various handicaps can use it, and this is becoming increasingly common, and there is a general feeling all around that handicap should be treated only as a challenge and not as a disability. The illustrations can go on, but the important thing is you must understand all aspects of man machine relationship comprehensively, so that you understand the user friendliness of designing machines, not to overlook the fact that unlike it was 70-80 years ago, man machine interface is neither discrete nor occasional, but it is a continuous way of life. So, further examples would help to illustrate what is sought to be achieved. How to design an alarm system so that surveillance staff do not get too annoyed by false alarms and do not fall asleep when there are no alarms. A very basic question in security systems. How to design a computer mouse so that users do not get strain injury when using it all day. How to design a toilet so that user can choose between small flush and big flush without having to read an instruction. And of course, in the process save water, which is so central to resource management these days. For this, it is important to understand the user profile and the situation. I give to you below a set of 7 questions which you may wish to take down or internalize and apply it to any product development issue, any design issue which you in your capacity as an engineer may be a party to or may be responsible in a managerial situation to give a feedback onto the product usage. हेलो जी, हाँ मैं Here is therefore really a checklist of questions which are not engineering questions, but are use questions, and given the kind of man machine relationship we are talking about, needs to be internalized into the design or the product development phase, and that will have its consequences on machine maintenance and field engineering. The last question, can we expect the users to know technical terms used in the instruction, is important, because from the illustration which I have already given to you with reference to computers, the technical terms can get to be fairly confusing and difficult if they are not used in the sense in which those words are used in everyday usages. And you recall my reference to expressions such as cookie or a bar. Using the person who will be actually working with the system in the design process is now generally being accepted as the way forward in handling issues of man-machine system, and potential users, it is being recognized, should be involved from the very beginning of the design process. There are two kinds of users that help to classify the system. One is the experienced users. Experienced users often have many suggestions for things that can be improved, especially from the perspective of the running of the machine for extended period in a trouble free manner, which will always have a feedback on the sales quantum, on the life of the product, and when upscaled, what components to upscale and what components not to touch. Very often, upscalability is carried out for the sake of novelty rather than any functional advantage, and that is not the best way forward. So, there are the experienced users and there are the novice users. Novice users are useful for asking the silly questions that the designer has not thought about. Silly questions have their own role in development. Silly questions are questions which an expert would probably term as axiomatic, would probably term as so irrelevant as not even worth tackling, but to a person who is entering the interface of the machine, it is so basic that this is the first question which comes to his mind. An example from everyday usages will help to establish what I am seeking to put across. Consider the different ways in which a tap can open. You can push, you can pull, you can rotate, you can turn, you can tilt, and you can simply pass your hand across a beam, if that is the common word which will be communicating what I am seeking to communicate in this situation. And the possibilities are almost so large and endless that as you move from your familiar terrain to a terrain which you are new and an area which you have not experienced, or move from one type of hotel to another type of hotel, you almost need a briefing on how to open a tap. Now, that is an example of what could be termed as a silly question. Who would think that opening a tap can be such an issue? Similarly, with the coming in of the touch screen and the emphasis on varying shades of luxury or comfort, switches have given way to touch, and touch has given way to pressure, and pressure has given way to how much light you can have with an adjustment, and all this is not quite clear to a person who has not been briefed. And indeed, the question arises, are all these multiplicity of choices necessary for everyday living which requires simple support systems of utilities, or is it merely adding a novelty value to a universal facility and thereby complicating what is basically simple? These are questions which can't be attempted to be answered here, but these are questions which cannot be ignored either. Therefore, when it comes to a man machine system, I have suggested to get a user feedback from the stream of experienced users and from the stream of novice users. Both types of users can be involved in usability tests as soon as the first mock-up or even just a drawing of the user interface is ready. So, the message is very simple. In case of engineering business, there is a definite case of involving the users, or as it were the non-engineers, to get their feedback, because in the ultimate analysis the products of engineering business are for mass use, mass interface, and they cannot be so specialized that you are expected to have an understanding of how the engineering system itself would be working. So, I would recommend for your consideration what can be called a usability test. Please go through with this. The usability test is the most important part of the design of user friendly devices, and because this is where you discover the problems. Tell somebody to use the product and observe him trying to make it work. But there is an interesting sideline to that issue to which I draw your attention, and it has been in the public domain for quite a while. If you do not understand the technical dimension of a product, which is the line that I have been pursuing in the last few minutes of my presentation to make it user friendly, what can you be faced with? Your voice calls recorded over 5 years, or places you visited the last year, or video calls you made in the last 3 months, or the emails you sent in the last 6 days, and indeed even the online chats in the last hour. All these could be accessed by someone at will. Therefore, your voice calls, your places of visit, your video calls, not to overlook your emails, and your online chats are all open to public scrutiny, because there may be a bug in your gadget. To install that bug is not a very complicated process, and if you are a part of the governance system, you can almost do it at will. So, what happens to the freedom of dissent of a governance system, which is considered so essential and basic to operation of a democratic framework? This sensor platform, and it is about time we brought in a few technical terms in this discussion, so that you understand what I am talking about, is not only for snooping purposes, but it can be a violation of basic human rights of privacy. Who would want to spend his 24 hours open to public scrutiny or at will of anybody powerful, not because he has something to hide, but everyone wants a few private moments where they do not feel they are open to scrutiny. Therefore, to get back to the usability test, I have interrupted your reading of the slide presented to you to draw your attention to the recent phenomena where proliferation of smartphones has made it easier for agencies to spy on people. It gives them an additional channel to monitor apart from snooping devices plugged to core telecom networks, a leverage which can be very painful and disconcerting. Indeed, smartphones are treasure troves of information daily user activity. Our phones today are collecting more data and storing more data than they were doing a decade ago. Those of you who are familiar with what has been in the press, with WikiLeaks, with Snowden and others, and the details are not relevant, you have had a view of what even international relationships are really in the real world and the distance they mark from how they are presented. So, while recommending to you solutions like write down all your problems the user encounters for application of the usability test, remember that the purpose of this test is to find errors or problems. One is essentially working at a very simple level of gadgets. There is a complicated level of gadgets, and the complicated level of gadgets has to do with security issues. It has to do with issues of privacy. It has to do with safety issues of information, and therefore, the need to recognize that we are living in changing times with reference to man machine relationship, just as we are living in changing times with reference to everything, and turbulence is a fact of life in all human activity, and the sooner we accept it and we get used to it, the better it is. To revert back to issues of identifying errors through usability tests, here is a possible listing of the kind of errors which you may find. The user has problems finding on how to use the product. In fact, here again I would like to interrupt my presentation with a walk down the alley of possible unexpected situations in which a user can find himself, and let me illustrate it with reference to a car. Everyone wants a secure system for a car for safety purposes, so that it is not stolen. As engineering has permeated the body of the car, concerns of control have become more and more ubiquitous, even in terms of window screens which are put up and how they can be locked, from where that can be locked, from where that lock can be released, and the argument has been that it reinforces the safety of the child who has been left behind in the car, or it multiplies the choices of security. You can't argue with that. What one needs to recognize is that with multiplicity of security control points, the risks of carelessness, lack of knowledge and sheer accidental lapse not to overlook a conscious misuse of these control points have added new experiences to dimensions. For example, there are cases where socially unacceptable behavior has taken place in cars by rolling up the windows, by locking them from a panel to which the victim would have no access and is rendered helpless because the car has been converted into a cage. If that was the end of the story, well, then solutions could be attempted, but the story goes on. That is a conscious misuse of the security device. But imagine a car, and there are illustrations of this, catching fire, and the control linkage has been snapped, the windows are up, the doors are locked, the passengers of the car are locked in, and since the control network has been affected by fire, the doors can't open, the window panes can't be rolled down, and you are burnt inside the car. Now, you have had illustrations just now of the conscious misuse. You have illustrations just now of being a situation of helplessness. Let me give you an example of something which has recorded history, where in certain types of high-end luxury cars, the security system is so thorough and so tamper-proof that just in case you have lost the key or the duplicate is not accessible, you have a situation where in case of a loss of a key or non-availability of a duplicate, there is no way you can gain entry into the car short of getting hold of the servicing system of the manufacturers, which may or may not be available in that city, and then you have to wait till the manufacturer and you get in touch on how to access that particular vehicle to get it started again. Now, I have no comments to make on that situation. What you have to ask yourself, the designer has to ask himself and the user has to ask himself, is this what creates a level of comfort, or would you rather change it? Be that as it may, to get back to the simple everyday illustrations and simple everyday choices, I would urge you to recognize that types of errors which user surveys or usability tests can throw up would include the user wanting to do something that the product cannot do. Now, this is the other end of the spectrum. I was talking just now to you of a situation where the product can do something and the user is delinked from the command giving key, touch, interface with the machine. Now, here you have a situation being highlighted, the user wants to do something that the product cannot do. Now, where do you rate it on a usability test? the product does not do what the user expects it to do. So, there is a maintenance issue, and the more complicated the cutout system, the more complicated the wiring system, the greater are the chances that the maintenance interventions which may be available to you are simply not good enough to set the system right. So, what do you do? If the price of rectification of a gadget error is higher than the price of the product itself, then what does it do to the market? And these are managerial issues of man machine interface which one needs to handle. The user uses the product in an awkward way, and then what results? So, these are errors which need to be identified and solutions found for them at the product design level itself. Now, here are a set of suggestions on methods of the usability test. In other words, what are the ways in which a usability test can be administered? Here is a listing of 6 techniques which can be used for undertaking a usability test. These are suggestions from the managerial perspective on engineering business. Why just engineering business? Any interface with a machine. Let me make it even simpler by saying, besides these methods, it may be simple merely to recognize that a simple toll free number easy to recall should accompany any kind of a product where in time of need the customer can merely dial that number, record what the problem is and stop there. I am not even recommending the manufacturer to render services of rectification, though it would be a great idea if they were these rectification systems were put in operation. But getting that information from the user is really free R&D feedback to the manufacturer. And I for one can't understand why the simple process of getting feedback is being not put to use when its impact could be so definitive over the sales dimension and over the competitive dimension. From methods of usability test which I was elaborating, let us move on to defining operational and functional effectiveness of the man machine interaction system. The general functionality can be analyzed by a set of questions. How many functions will be controlled by this interface? Because the interface would be requiring a human command. The same can be converted into an automatic control system, but then converting it into an automatic control instead of requiring a human command would have its own complications. The complications would be in the form of a circuit problem, a complication which cannot be maintained by interventions of rectification available easily at hand, and thereby rendering the entire machine dysfunctional. Or the listing goes on to say, where a single function might be served by a push button, key lock and rotary switches, multiple functions could require several screen displays to cover operator functions and options. Read this very carefully, because it sounds like a little complicated. It is really very simple if you have followed the sentence, and I will read it out for you again as you try to read it yourself. Where a single function might be served by a push button, key lock and rotary switches, multiple functions could require screen displays to cover operator functions and options, and each stage you check whether the user wants to continue. The next question: what kind of visual, auditory or tactile feedback will serve the operator in performing the defined functions? Does the operation require real time indicators? And finally, an emergency stop or switch may be installed. To continue with the elaboration, I think I would like to briefly touch upon the degree of input complexity. The input can be simple as an on and off switch or a touch screen display. A touch screen machine man interaction systems are really on the way up today, because these transfer applications simplify complex operations. And what is equally important in terms of usage, because all consumers are not equally sophisticated, all consumers do not have the same level of sensitivity, the equipment is bound to put to rough use, or rough use is inherent. Let me give you an example. Any mobile handset is a sensitive gadgetry. Any bump can affect the circuits, but then all mobiles do fall, do slip from the hand, do come out of the case in which they are put, or do fall out of the packet or the pocket, or slip away from the table. What do you do then? If the gadgetry is fragile, you have a problem at hand. To carry the discussion further, defining input requirements will help decide which control technology is best suited for a specific application. It is also important to get an operator feedback. Read this screen. Treat this merely as a listing. This is by no means an exhaustive situation, but it is indicative of the role of an operator feedback. The concepts are simple, self-explanatory, therefore, I am not going to take any time out to explain it beyond what has already been stated on the screen. The interface or interconnection with other systems is described in an equally simple manner. You may wish to read through it carefully or take such ideas down as may be of interest to you. Nothing complicated, but what this presentation does is builds into your cognitive system the recognition that interface and interconnection with other systems is a concern in dealing with machines, a concern which sometimes is not built into the design or the production processes. And of course, the style. The man machine interaction system style is high priority for many consumer goods and especially luxury products. In the marine industry, the consoles for high performance racing boats feature contemporary styling and an array of ergonomic technologies, and marine industry is not the only industry. Man-machine interactory style considerations are effective when they create a level of products differentiation that delivers a unique selling advantage, and back you are to seeing an interface between profits and engineering action. Very simply, management and engineering have to work hand in hand. Inevitably, the regulatory and the standards consideration would come in, because a knowledge of the technical ergonomics design and manufacturing standards is fundamental to these considerations. These include engineering standards, industry guidelines and more. It is not for us here to get into these guidelines or to discuss them, but it is certainly our business to draw your attention to the existence of such considerations. Now, this will have to be integrated with stages in product development. I would like to draw your attention to the need of referring to old versions, the prototypes, the beta versions, the final product issues and management of products, which are important, but which are not central to understanding how man-machine interface or interaction is positioned. This is more by way of the solutions which will need to be sought for the problems which would arise in this interaction. So, I would leave that with your thought and try to conclude this presentation by reminding you that, like everything else, man-machine system has backward linkages and forward linkages in a manner in which solutions can't be found unless you take an integrated perspective on the exercise itself.